Thanks everyone for joining us for today's webinar. My name is Eduardo Sorto and I'm an application engineer with Tech30. And today's topic is going to be focusing on Creo's Advanced Framework Extension. So I have this agenda here outlined for you guys about what this demonstration is going to entail. So first thing I'm going to do is just introduce what the AFX extension is for any of you who have not heard of it or have seen it in action before. Then I'll talk about its capabilities and different functions that are available, what the process looks like in terms of a user standpoint. So we'll go over a common workflow. We'll jump onto the demonstration to see it in action, and then we'll analyze the business impact, see what the value is here, and do a summary of the demonstration. And of course, feel free to type up any questions if you have them in the chat box, and I'll get to them at the end of the demo. Okay, so the Advanced Framework Extension provided by Creo here is focused on enabling structural engineers, designers, to be able to design these large structures, frameworks, steel beams, structures in a very efficient manner, right? So whenever you're starting a design for a framework, there are several different challenges to face, right? So the largest or the most common challenges here is being able to manage all the different features here and parts that are all modified based on different sizes and profiles of your design requirements, right? So you're going to end up with a large assembly of different parts that you now have to manage and keep track of their profiles and the connections and all these different parameters that are now being tailored and redesigned from the manufacturer, right? So you need to keep track of all those different modeling changes. And I've seen a lot of people do this manually, where they have their profiles be created through a sketch, and it can get very difficult to maintain, right? So we want to be able to optimize that and, of course, improve the performance of dealing with large assemblies, as well as having accurate BOMs in the end. Okay, so here's an overview of what the AFX is and what it currently offers. So its main priority is to optimize design for large assemblies, right? So it uses top-down design techniques where you can capture your design intent at the very beginning of the design, right? And this here pushes the design intent captured in the beginning to the rest of your assembly and your models. Right. Also optimizes large assembly design by being able to eliminate assembly references or cuts. So there's less regeneration happening in the background to look at those references. And it also works to automate your drawings. So within the actual module itself, it has a function where you can go ahead and create a drawing from all the different beams that you created within the AFX tool. So again, making it easy to have a comprehensive output of your design. Okay. And as a part of the module, you also have a large set of libraries that include different profiles, equipment, joints, and it not only has those different dimensions and sizes, but it's also has built-in standards. So you're able to meet those standards, figure out exactly which part number you need, and be able to push that into your assembly without having to go to a different source or different library. It's all embedded within Creo. Makes it a lot more easier to maintain, and definitely a lot easier to captivate all that within the drawing environment. And the last big point here is to encourage designers to reuse designs and automate the process of simple, addition of parts where it shouldn't be, complicated. So all you're doing here is leveraging the existing libraries to reuse these profiles, these different constraints different bracing connectors, any of that, you'll be able to quickly reuse that from the existing library. So this definitely makes it a lot more easier to automate the process. Okay, so next thing I'm going to jump on here is going over what the the workflow looks like when inside the AFX module. So I mentioned before that the AFX leverages top-down design techniques. So this is really best practice of maintaining all your design intent in the beginning of the design phase. So if there are any changes to be made later down the road, you have that within one source for change, and it's easier down the line to have multiple people working on this to be able to locate where and why your specific design choice was there in the first place. So again, captivating all that within one place. So here, first thing is creating a sketch. It doesn't necessarily have to be a skeleton model, as you'll see in the demonstration, but it does definitely help when you're dealing with a large team to captivate everything in the skeleton and then pushing those features down to your different teams. But the idea here is to captivate your the placement of your beams, the connecting parts, all within the sketch here, right? And of course, it's embedded within Creo, but you can also import any sketches from third-party applications. If you have maybe just a 3D sketch from a different source, a different designer, you can import that and work with that within your Creo environment. So that's the very first step to ensuring that you have a successful AFX workflow. Now, the second thing here is exploring the libraries that Creo offers, right? So after you've laid the foundation of where all those beams are going to be set, you'll then select what profile, what style, what size of beam you're going to work with. And as you can see in this page here, there's a variety of different standards that are provided. So you can toggle not only through these different material and shapes and dimensions, but also the standards and types that are provided within these folders themselves. And of course, you can go ahead and add to them, add your own folder for your specific company standards or most common used, and configure this as you like. Okay, so once you go ahead and decide what beams you're going to use, all you have to do is really select those curves that you created in the sketch environment. And we'll touch on that on the demo, but here I just want to show that once you go ahead and place those beams, next thing you'll want to work on is those joints. So how those beams integrate or connect to one another. And so you'll have to create those cuts. And before, again, they were done manually, and the mating process was very difficult, but you'll later see in the demonstration how easy it is to place, to create these joints, and create the style of joints so you can later recycle them for the different parts of your assembly. Right, so here, this joints pop-up basically gives you a variety of different options to configure those joint types and different offsets if needed. And all you have to do is really select those two beams. It'll recognize the faces which they integrate, and again, cutting down the assembly references that will lag your performance. Okay, so the next steps here are setting up your end plates or bracing. Really, this is all the different parts of how you're connecting your beams. So all this is, of course, integrated within the AFX module. So same thing with the profiles. You have different types of libraries associated for end plates and bracing. So you can select between different styles, different sizes, and then the placement, again, it's very simple. Depending on what your connection type is, you can select between faces, curves, and add your parameters there. Okay, so this here, I want to include this set here to just outline that it's not only working with beams and structures, but the entire framework design. So this includes your stairs and your different styles of beams to work for stairs specifically. So you can go ahead and build out a sketch to later use for your stairs foundation. So again, this is an automated process that you can use within the module. What's also included is this smart library for placing screw connections to your model. So this here is an automated process where you can pick out which standard you're going to use, what are your dimensions, and it's able to recognize these where you created these end plates and bracing mechanisms, so you can go ahead and quickly add those hardware to your assembly. And really the entire purpose of having all of this captivated within the AFX module is to produce a comprehensive drawing of your assembly, right? Keeping track of all the different cuts, sizes, different shapes, standards can get very tedious, especially with a very large assembly. So AFX includes a drawing function where it creates it based on an assembly, top-level assembly, or a parts in particular. So this will captivate all the different hardware used, different sizes, profile standards, and all to give you a comprehensive BOM in the end. So again, the intent here is to optimize your framework design and to make it a lot more efficient to work with these large assemblies. So this is the last slide before the demonstration. So I'm going to quickly jump onto Creo and pretty much show you what the process looks like. I won't have time to touch on everything, and of course not the more advanced stuff on this for this module. I just want to introduce what the environment looks like for a new user if you've never seen this before, and how you can quickly compare that to what a typical workflow would look like. So I'm starting off with a simple assembly here, and really I want to focus on this sketch here. So we have an environment in which it looks like a plant assembly, right, where you have a pressure vessel in the middle, and the intent is for the designer to go ahead and build a structure around it to either ensure the safety of any operators, or a second level structure for operators to go ahead and access different parts of the vessel. So here, our task is to go ahead and create that framework within this steel podium assembly, right? And if we go ahead and simply expand this assembly, as you can see, there's no skeleton features on this. So I built out these sketches within the assembly environment. So there's no parts here within the assembly environment. And so I'm just going to simply use this to captivate things where the beams are going to be placed. So this makes it a lot easier. But of course, if you're working with a large team and you want to use those copy geometry and publish geometry features to push your design intent from a skeleton to different parts of your assembly or models, that skeleton feature is going to be beneficial. But for now, we'll keep this simple and just use sketches on the top level. Okay, so the very first thing I want to do is introduce, the library. So I'll just start with this current sketch that I have. I activated the assembly, so whenever I do place those beams, it's all being placed within this assembly here. And I will navigate to that framework extension. So the framework extension has its own dedicated ribbon. So you can see here that these are all the different features that you can go ahead and optimize or modify your beams when you're placing them. So the nice thing about the UI here is that it works from left to right, similar to how we had those PowerPoint steps outlined. So you'll start off by creating the sketch, the profiles, the different connections and end plates and bracing. So we'll work from left to right. So whenever you're starting with a new design, you'll want to create a new project. here I have one already defined. I'll just get this message in the background telling me it's defined, and then you can go ahead and modify any parameters for the specific project that you have. If you have any parameters or relations, you can have those inserted to be pushed. You can specify different options and item numbers, prefixes that you need to configure for those beams. You can go ahead and specify them here. And then once you have your project defined, you'll want to start creating profiles, right? So I have this sketch that I'll start with in the beginning, and I'll just explore the profiles that are provided for us. Okay, so the very first thing it does is it gives you this window here, and if we click on that folder, we'll be able to see the library that Creo offers. So these are all the different types of standards and libraries that are offered by Creo just out of the box. As you can see, they have different types of extrusions, and all these dimensions are you're able to edit them and configure them if there are any custom dimensions here. So again, a very large set of library here. And what we're mostly interested in is just a simple, steel beam that we'll use for this example. So really what I want to do here is place a couple rectangular beams here and maybe some square beams in the bottom. And if we have time, we can go a little bit more, do a little bit more complicated example with extrusions and see how they connect. But for now, let's explore this rectangular tube profile. So as you can see, once I click on that profile, I'm then given another window with all these different standards available to me. So within these standards, you have your own dedicated sizes. So it's very easy to keep track of all your different parameters for that beam you're going to place. Okay. So for this, I'm going to go ahead, since I'm working with millimeters, go and select this 120 by 60 with the wall thickness of 5. So you can see the diagram where these parameters are for. And now go ahead and select next. So I went ahead and selected my type of beam, my size, and here I have the option to assemble this into a new subassembly within the steel podium assembly. But for this example, I'll just have it unchecked, so I can go ahead and just have everything populate within that steel podium. And then here you can specify the material too. If you have anything, a different profile that's not necessarily steel, you can go ahead and specify that here as well. So go ahead and click next, and next thing it's going to prompt us is to positioning and placing those beams. All right, so I have my standard here. I'll go ahead and select my reference. So let's click on this curve, right? It's the automation process is basically recognizing the endpoints of that curve and placing it. And to make this pretty efficient, you just hit that repeat. It automates, or it brings forward all the different sizes and standards. And you just repeat the process and place it on a different curve, right? Now notice here that this place the beam on the vertical axis. So this tool makes it easy to just rotate that and configure it if need be. Okay, so I'll just start with those two. Actually, let's go ahead and do these as well. I'll go ahead and rotate that, repeat, rotate this. Right. You don't have to worry about creating any of these profiles. I don't have to worry about creating extrusion cuts for these profiles. It's all integrated within this environment here. Okay. Now, another thing I want to demonstrate is that once you place this your beam here, you also have the option to move this along a different center point or center line than the curve you created. So at the moment, this has the center line in the middle of the beam here. Maybe we want to have that on the edge instead. We can go ahead and use these move features to really capture what your intention was when you were creating these curves. Maybe you wanted this to be the outline of those beams. You can go ahead and move that here and be able to, instead of having to resketch this, you're able to just do everything within the AFX module. Okay. So do the same thing here on this end. I'll rotate this, and then I want to be able to have the edge of that beam align with the edge of that curve, and I'm done with the placement of this top sketch. So after you've placed it here, you can go ahead and define your joints, and you have different options for joints. You have the basic category where you have the most common profile ends, and then you can get a little bit more advanced, as I'll show later on, when you have different types of cuts and profile ends that you have to work with. So for this example, I want to do a simple joint that pretty much has these two beams aligned at this one point. So after selecting the type of profile ends, I'll select the first profile, second profile, and it automates this process for me. I can repeat that and do that for this beam, and does that for me. And I can define a different end for these two profiles here. So click on this one. This is my first end. This is my second. See how quickly it's able to just cut these automatically. And let's do this again a couple more times, just to show you how it's pretty much just optimizing the time it takes to go ahead and create all these profiles manually. Click here, and there you go. And as you can see, it populates an annotation to give you the size of these curves, and it's all captivated within the model, or you can go ahead and turn these annotation displays off, on and off if you like. Okay. So now I want to go ahead and build out these three tubes here and show you, what an advanced joint looks like. So first thing I want to do is add a square beam to this. So I'll create a new profile. I'll create a square tube, and let's see if select a standard here, something that's 120 by 120 with the same wall thickness that we chose. So that's 125. Yeah. Right, and this is a typical process, what it looks like, when you're designing something like this. Of course, your beams or your design would be a lot different. This here probably isn't the correct way to design the structure, but this is just to show how simple and quick it is to add these beams. Again, go ahead, we'll move this so it aligns with the edge if we want it. Click OK, and say you forgot to move this in the end, you can go ahead and select this Move Profile option, select your profile, go ahead and select what the center line is, and there you go. It was a quick modification to the part. So now I want to go ahead and specify how these connect. So I'll go ahead and do a basic joint here, click on this profile, click on this profile, it cuts that for me. Okay. And do the same thing for this profile, and then this top one, it's able to cut that. Okay. So now what I want to show is having edits to this current design. So maybe I want to add a bracing member that goes through these two tubes. So instead of building out from here, the AFX module I mentioned, it uses top-down design. So you can go ahead and work within the sketch itself to define what that additional tube will be and where it's going to be placed. So for this example, I'll just have a simple cross member here, right? And I can go ahead and build a beam from there. So it was very quick edit. And all I have to do is, again, place my beam. Let's choose a different type of beam this time. Let's go with the 120 by 60. Okay. Click on next. I'll place my beam on the new curve here. Let me go ahead and rotate this. Now notice how this connection here now has two different profiles that it's meeting. So this is one of the advanced joints that we'll have to work with, and really it's quite simple to use depending on what your design constraint is. You can go ahead and create a cutout where you draw out the joint, or use a planer and use references to use to trim. So here, my references, first thing is the model to trim, and then the second is a plane or a surface to trim that part. Right. And really, it's called an advanced joint, but it's nothing complicated. It's just away from those standards that are within the library here. So as you can see, I very quickly went ahead and modified this beam here to align with these two other beams to meet that corner correctly. So now when you populate your drawing, you know that it's going to be correctly mated to these, and your dimensions are going to be accurate at the end. So now, say I want to move to the next step and add bracing member to this, and I'll go ahead and skip the joint for this one just for the sake of time, but I'll go ahead and create a connector element. So this is the connector element window has the different end plates and bracing options for you. So again, having a standard library and non-standard options available to you to quickly be able to leverage whenever you're within the AFX environment. This is very nice to use. So for this example, let's see, we'll explore a couple options that we have here. We can see that it has different connection types for different types of beams. You can go ahead and create connections that are embedded within the beams themselves. So if you have to add hardware there, you have those cutouts already created for you. So you can explore, what are the different options here based on those standards, and really make it a lot easier for you to add different parts. So for this example, I'll just do a quick rectangular brace. And when I'm working with this environment, it's going to ask me what my profile sides are, and you can see a diagram here to make it a lot easier to select. So this really, it's easy to get started. So my first profile end would be this face. Second will be this top face here. Third, this face. Right? And I can specify the dimensions for that brace. So you can you have the option to modify any of these parameters if need be. You can measure from within this environment. You use this tool, measure, or if you have a specific standard you have to follow, you can do that here, and you have the preview option as well. So a really good environment to work with. So as you can see, it went ahead and populated the brace here, and of course I can get a little bit more into detail and start adding connections and hardware. But I just wanted to give a quick introduction and just demonstration of how quickly it is to add these beams, change the profiles, manipulate the connections, manipulate the joints, and once you're satisfied with this, next thing I've seen people do as well is start adding weld elements or weld features. So if you're not using bracing or bolts or connections, you can also tag this extension with the weldment application. So if I jump over to applications here, this is already included within the base Creo license, so everyone should have access to this welding feature here. And really, you can start adding these features to captivate not only the different welding notes that are needed for the drafting environment, but also if you need a very accurate or a more accurate a mass total for your assembly, you can use these weld features to go ahead and calculate the mass needed as well. And you can push these weld features to your simulation environment, so it's a more accurate representation about how these two interfaces are connected. So again, lots of things you can do. So here I just want to demonstrate, how quickly it is, how beneficial it is to add these two different modules here, right? So this here creates a weld feature, and it has the call out note for your specific weld feature as well. So this here gets pushed to your drawing environment. Okay. And another thing I want to show, just because I've seen there's a lot of questions to the weld feature here, is you can add materials to them if you make them a solid. So if you go to your option to make them a solid and define what your cross section is, your material, your process, any of that, modify your annotations, and then have that all be pushed to your drawing environment and simulations or comprehensive mass analysis, all captivated within the assembly here. So this was just a quick demonstration of how to get started with the tool. What are the different options? How does the UI look like? How easy it is to use, and just so you can compare it to any workflow that you had to use in the past, or if you're exploring different options here, just how to get started. So we have about 5 more minutes left, so I'll go ahead and open it up to questions. I'll just wrap this up with some quick summary of what the demo was and what the AFX extension offers. So I mentioned that it's easy to create these beams, select spec out the profiles, and place these beams. So this works to produce quicker designs, and of course it results in a reduced time to market. You also have the ability to customize very quickly, make modifications very quickly to the model if you have to add different beams, change the beams out, modify the styles, standards, all of this. Since it's all embedded within Creo, it's all in one location, makes it very easy to improve those modifications. And then lastly here, it's improving the entire framework design, the quality of the design, not only in terms of efficiency, but also accuracy. So when you're generating drawings and BOMs, since everything is within Creo and automated, it's very easy to push those parameters and standards to your drawing environment, and it gives you a huge leverage when you have a library to work with. Okay. So I'll go ahead and open it up for questions. If you have any, I'd be happy to answer them.
All right. Thanks, Eduardo. Great presentation. We do actually have one question, and that question is, are you able to create your own profile and add it to the AFX library?
Yeah, thanks, Joe. So that's a good question, and I've seen it come up a couple times in the past. So you can definitely modify the existing library, or you can create your own, similar to how Creo stores templates. So within the Creo common files, you'll be able to see all those different standards. So it usually comes in text format, and you can either edit those texts to add your specific parameters, or you can create a new one from a sketch. You can you can import that sketch into the common files. So that's your new profile. So yeah, very, very, it's very configurable, and you can definitely add as much as you want or edit as much as you want on there.
All right, thank you. Once again, just want to remind, since we have a intimate crowd today, if you have any questions, feel free to drop them in the chat or the question box. But as we're waiting for any other questions that may come up, I want to remind everyone to, if you get the chance to, follow us on Twitter, Facebook, LinkedIn, and YouTube. We'll be posting this webinar later on today, a recording of it. And we also have recordings of previous webinars, both from Creo, MathCAD, and Windchill. So we encourage you to follow our social channels just to get this extra content to help you with your software. And but other than that, it looks like we have no more questions. So I just want to thank everyone for coming today, and thank you, Eduardo, and thank you, Ron. Have a great day.